to the left and right. All right, fire the laser.
Do you ever service these?
Hey guys, this is Gary coming back to you with another fiber laser install. This time we're heading up to a short drive, 5 hours away, Little Rock, Arkansas. And you see Matt pulling out here with the machine, heading up that way to take the machine. The previous two clips were in the shop where we just got the machine kind of up and running, did a test fire on it, made sure it was moving around so that when we get on site, the problems that we run into are going to be limited and we can get right to work on training and dialing in. So here we are at the shop of Ross's place. I'm not going to say the name. I don't know if he wants the name of his business getting out there, in detail. But very nice facility he's got. Just giving you a little quick tour on Ross's facility. And about a year or a year and a half ago, he bought a 5-foot, 70-ton fabricator press brake. And you can see it right there. And they use it on a daily basis or really a weekly basis. So these guys do quite a bit of things related to motorsports with a primary focus on the side-by-side market. And you see the CNC machine they got there. They make a lot of suspension parts that are, target the side-by-side world. And you can see these suspension components here. A lot of, laser cut fabricated parts that they bend up on the brake. So I always try to start off with the very easiest material in the dead sweet spot of what these machines can do, which is thin carbon steel, thin aluminum, cutting on nitrogen. It is the most easy to dial in, the most forgiving, and you can see right off the bat, the very first cut here, cut great. That was micro jointed, otherwise it would have fallen right out. And then here's some 16 gauge carbon steel cut with nitrogen, and when I say burr free, I mean like zero burr on the back, perfectly smooth to the touch. So this is a 3 kilowatt 5x10 open machine, 1G acceleration, running set cut. And Ross's facility is a 3-phase facility. He's got 240 volt 3-phase power. And so here we did a little engraving, so kind of showing Ross how to set up the engraving, but we cut each of these with a different focus position. And so it's just a way to kind of see where the machine's wanting to be focus-wise. So this was 1/8" aluminum, kind of stepping up in the thickness. You can see it's running a little bit slower here. The one thing about aluminum cutting on a fiber laser, and it doesn't matter if you have a $100,000 G-Force machine from me or $1 million Mitsubishi or Trumpf, you're going to get a burr on aluminum when you get over the thickness of around 040, 050 thou, somewhere in that range. You'll get a burr on aluminum, nothing that can be done about it. So over Thanksgiving, Ross literally just put up this new addition to his shop that's going to be dedicated to the laser. And so he built this out, poured the concrete. You see it's got an overhead crane that he's incorporated in there. I think he's got a 1-ton or 2-ton hoist on it. You can see the cradle of oxygen bottles back there. And then he's also, over to the left, we'll show you in a little bit, he's got a metal storage rack to store all of his materials on. So here we're just working on 1/4" stainless, and we were cutting a series of holes, making adjustments to the focus and speed and nozzle size, nitrogen pressure to try to get the best cut that we could. So the one thing about cutting circles that most guys probably know this, but you can cut a circle with a target cut speed faster than you can cut a square with a long straightaway. Because a circle, the machine never reaches the full speed on a medium accelerating machine like this one. And that's where the G-force and the high acceleration comes into play. And so this is being demonstrated right here. So we're cutting some 1/8" holes in 1/4" stainless and then doing a little bit of engraving on it. And you see right here where it goes to cut the outside of it, and it reaches full speed by near the end, it'll start rooster tailing and not cutting all the way through. So it's just about 5% too fast.
Okay, so shutters off.
So as I mentioned earlier, nitrogen cutting has a pretty broad range of what can work. And so I was just demonstrating to Ross here that we could take a sheet of, I think a little drop of 3/16, or it might have been 1/4 inch, I can't remember, carbon steel, and use the stainless parameters that we just dialed in and get it pretty close. Now you can, always tweak and dial in and, fine tune to get what you want. But you can see here we got a really nice result right out of the gate. Go ahead.
Ready?
Mm-hmm. So here's a little peek at their Bentech Dragon. Obviously, building suspension components, they do a lot of tubing, cutting, bending, that kind of thing. So switching over to oxygen now, our very first oxygen cuts. Let's see how good we can do. Oxygen definitely more finicky, more tricky to dial in, but once you kind of understand the focus range of any machine, you can apply that to other materials and kind of get where you need to be.
Not bad. Put the tab on there to not drop it.
Got a funky spot on it. I think it didn't like that speed.
Definitely is a lot cleaner on the other one.
Go ahead.
Definitely.
All right, so we just finished up 1/4 inch there, as you saw, and now stepping up to 3/8, and you'll notice here that we've gone to a 2-stage pierce. So when I dial in a machine, 3/8 is about the point where I add a 2-stage pierce. Yeah, I mean, you can technically bust through there with 1 stage, but when you're setting up piercing, you really want it to get a pierce routine that's consistent and reliable across production work. Was it just a micro joint, or did it have a place that didn't?
It had a...
Oh, at the lead in, it's got a big...
Yeah, it kind of boogered it up.
So we went 3/16, 1/4, 3/8, and now we're jumping over to the first attempt at 1/2 inch. It might have actually been the 3rd attempt. You can see there's already 2 holes there. And you'll see we're kind of struggling with the pierce. But we got it. And, here's a look at a full first, cut where the pierce was good, and we're pretty happy with everything. You see the pierce getting through there pretty quick, not too violent. This was some 1018 cold rolled 1/2 inch flat bar. So not a material that, in the laser world that you get to cut a lot of, but he's got a specific suspension part that he does some extra machining on in a CNC mill. after the laser cut process. So he wanted to use 1018 flat bar. He likes the thread engagement and the way the drill and tap works on the thread compared to 836 or A572.
Looks like it dropped it out.
It's on a slat.
Yeah, it looks clean though. So it is dropped.
All right, so now we're into a full nest. Actually, it's just a half sheet that's been nested, but it is production work. It's some of his main parts that he cuts on a regular basis, and this is 7 gauge, which is around a little bit under 3/16. It's like 0.180 inches, or a little bit under 5 millimeter for you metric guys. So on your very first nest, you're going to find out very quickly about your lead-in strategy, about your micro joint strategy, what's working, what's not working. So we were stopping and starting and checking things out, looking at the cut quality, dialing in parameters, and then finally got, a little way through it and kind of got to where we wanted to be, and then just let the thing rip. So I'll just let you watch some of it, and then we'll pick back up on the next step.
So we need to modify our
So you saw all those parts dropping in the tray there, and a couple points about that. One is when you're oxygen cutting, or really any kind of cutting, you really can't let the parts drop in the tray because as it continues to cut the other parts next to it, the overspray or the wash coming down from the cut job, the hot sparks will land on those parts and really mess them up and make them look bad. So you gotta, if they're dropping, you gotta get them out and then tweak up your micro. The cool thing about Ross is he's a super quick learner. I mean, I do the training the same with all the guys that I sell machines to. I don't really show you a lot. I just hand the remote to you, stand back, kind of give you some direction, and then I'm hanging around, hovering around, kind of letting you learn and just jumping in where you need it, but not giving you too many answers. And, I work with a lot of different guys, and their learning style is different. Their aptitude to pick this up is different. Myself, I'm a very slow learner, and it's pretty cool when you hand a remote over to someone and they just, take right on and kind of, I can be honest, the laser software is super nice. The SipCut software, importing drawings, setting lead-ins, nesting, all that. If you've ran any CNC machine before, it's pretty intuitive and pretty easy. The real tricky part is in dialing in the parameters, especially with oxygen cutting. So Ross wanted, he's outsourcing the laser work now, and he's not terribly unhappy with what he's getting, but they have a higher powered laser and they're cutting his parts on air, and air cutting has, some limitations. One of them is that you'll always get a burr and you won't get that smooth of an edge. The edge will be uniform looking and not terrible, but it's just not that smooth. And so Ross wanted a more refined process. He wants no burr and a smooth edge, or as smooth as you can get it, coming right off the laser. And so your really only option for that in carbon steel is to cut with oxygen. Oxygen cutting just so happens to be the most finicky, difficult part about running a laser. It's the most volatile. It puts a lot of heat into the part, and it requires a nesting strategy where the sort order is bouncing all around the sheet. All right, guys, we're gonna wrap this one up. Just still cutting this nest out here. I think it had about 11 or 12 minutes it estimated on this cut job. So big thanks to Ross. I didn't show a lot of the details of the outside of his shop, but because it's on his private residence and his house is next door, family, kids, the whole bit. And then also the side-by-side world is like super competitive, it seems like. And so, a lot of guys that make the parts for these don't really want to show a lot about what they're doing because, they're trying to keep the competition down. So anyway, big shout out, big thanks to Ross. Bought the press brake from me last year and then got the laser this year. I have a feeling we'll be back up there sometime in the next year or two with another bigger machine of some kind. But if not, always here to help and support Ross. And thanks, guys. See you.